Hello, my dear students. Good morning. Hope you're all doing good. Right.
Good morning, sir.
Yeah, morning. Okay. Yes, thank you, Arman. Thank you. Yeah, today is supposed to be Teachers' Day. I totally forgot about it. I started getting messages from students in the morning. Then only I realized that today is Teachers' Day. Right. Okay. Right. So we'll start. Right. We'll start right away. And guys, for your midterm exams, yes, Amrita, thank you, everybody. For your midterm exams, do you have metals and non-metals chapter for this thing, for the portions? Is it there in the portions?
Yes, sir.
Okay, metals and when is your science exam, midterm exam?
Sir, are you asking about the term 1 exams or the school exams?
No, not the term one. Do you have a midterm? Because for 11th and 12th.
Yes, sir. 9th we have, sir.
9th. Okay. So anyways, we'll complete it today, most probably, right? Okay, let me share my screen.
So that we don't have the full chapter shown.
Okay, so I need to see 10th, last class, what we saw. Not this, first, right. Okay, right. So last class, we saw only 3 reactions, people, right? Fine. So we already saw action with acids, right? I know certain metals will react, certain metals will not react. We even saw action with water. Different metals have different reactivity, hot water, cold water, steam. If it is going to be steam, I'm going to form only the oxides, right? So then we went on to see basically this category, right? Here itself, I can tell these are metals reacting metal plus non-metal. Right? Metals plus non-metals is what we are seeing now, right? So obviously metal with oxygen, again, oxygen is a non-metal, right? Now it's very simple reactions from now on, right? When I say metal plus oxygen will react to form metal oxide, very simple. All you need to know is how the metal exists in the reaction and on how oxygen exists in the reaction, and obviously due to the formula. Oxide ion is O2 minus. Right? And obviously, according to the metal, the formula will change. Right? Okay. Then we went on to see, I told you, okay, here there are little things you have to remember. There are oxides, there are metals, I would say, right? There are metals which can form 2 cations, right? One is what is your iron, right? And the other one is what is your lead, right? Lead can form +2 as well as +3. Same way, iron can form +2 as well as +3. Right? So if you look at the oxide formula, you will have PbO as well as Pb2O3. Same way, FeO and Fe2O3. Both of them will be present. Both of them are possible. Right? And actually, there is one complicated thing which can happen. I have a formula like Fe3O4. Have you ever come across this formula, people? Fe3O4. Have you ever come across this? Has anybody come across this? Yes, no? Fe3O4. No means no, yes means yes. Anybody?
No, sir.
Can you speak louder, Kana?
No, sir.
No, right? So basically, this kind of oxides, I even have Pb3O4, right? Now, what happens here is that here, in this case, I will be able to write this particular compound as Fe plus Fe2O3. You just add these two. Fe, I mean Fe plus Fe2 becomes Fe3. O1 plus O3 will become O4, right? This particular oxide is what is called as ferric oxide, right? Now, remember, whenever you have Fe2 plus ion, it's called ferric ion, right? And whenever you have Fe3 plus ion, it's called ferrous ion. Okay, remember this. These are the terminologies you have to remember. Okay, Fe2 plus, both are ion ions, both are ion only. right? But if it is going to be Fe2 plus, it is going to be called as ferric ion. And if it is going to be Fe3 plus, it is going to be called as ferrous ion, right? So FeO, I call it as ferric oxide, right? And Fe2O3, I call it as ferrous oxide. Okay, obviously Fe3O4, I told you, is a combination of both of them, right? So you call it as ferric oxide, right? Good terminology, right? Fe2 plus is ferric, Fe3 plus is ferrous. Same way you have for lead also, but we don't have to go into details. Iron alone is sufficient for your level now, right? Okay, then we went on to see metals reacting with halogens, right? Now halogens, I know what are these halogens: fluorine, bromine, chlorine, and iodine, right? All of them will form what ion? X minus, F minus, Cl minus, Br minus, I minus. Those are the ions which will be formed, right? And how they exist in nature? They exist in nature as X2, Cl2, Br2, I2, F2, right? So how do you write the reaction? This is how you write the reaction. M plus X2 will form the metal halide, right? Metal plus halogen will form something called as metal halide, right? Now we know metals will always exist in monoatomic form. And just now I told you that halogens, all non-metals will generally be diatomic, right? Here you see chlorine is in diatomic state, Cl2. So now eventually they'll react to form sodium chloride. I know chloride ion is Cl minus, sodium ion is Na plus, right? Only in the product side you have to go for ion formation. Okay, right, fine. Next we saw, all these things are same, right? Next we saw metals with sulfur, right? Now sulfur is S, again it exists as, I told you it exists as S2, S8, S6, all these things are possible, but in our reaction we'll take only S2. Okay, and remember, obviously metal plus sulfur will form the metal sulfide, right? Now metal sulfide is, it's written here, sulfide is S2 minus. Right, again, if at all you don't want to mug up this, you can always go to the electronic configuration and check how many electrons are required to form the octet configuration. So you find that 2 electrons are required, so you'll form S2 minus, right? Okay, anything else? Yeah, again, we saw this same things, nitrogen sulfide, sulfate. Now, some of you had confusion with IDE, ITE, and ATE. So again, we saw that, right? Okay, then we saw the reactions. Mg plus S2 forms magnesium sulfide, that is MgS. Hydrogen plus sulfide will give you hydrogen sulfide, H2S. And again, I told you there's an important thing here. H2S it will have a rotten X smell, right? H2S will have a rotten X smell. Okay, right. So the next reaction will continue. I don't know which reaction is this number. Okay, there is no number. Okay, we will put it as third. Right, say metal plus nitrogen. Again, see, we are still looking into metal plus non-metal only. Okay, right. Now, nitrogen exists in nature as how they exist in nature, people? Nitrogen exists as nitrogen will exist as
N2, sir.
Nitrogen will exist as what?
N2, sir.
N2, like you don't have to think about it. Generally, non-metals will be diatomic state. Nitrogen is a non-metal, diatomic, right? So a metal plus nitrogen, if I say, it is going to be what is this? N2, right? Will form metal. Can you tell me what should I write here? Metal what? Any guesses? Metal plus nitrogen will give you metal. There's one moment. There is some noise. Okay, better. Right. So yeah, what should come here? Metal plus nitrogen will form metal what? What is the compound name here? Metal?
Nitrate, sir.
Think about this. Only nitrogen is there. So what should come here? Huh? Yes, can it be a little bit louder?
Metal nitrite, sir.
Nitride. Very good. Very good. Again, whenever I tell you IDE, only that element is present. Nitride means only nitrogen. Okay, can someone tell me what is this nitride ion? How it will look like? What is the formula of nitride? Go for it. Write the electronic configuration, right? And check what will be the ion formed for nitrogen. Nitride, basically. Nitrogen atomic number is what? Nitrogen atomic number? Nitrogen atomic number.
So 7.
Sorry?
7, sir.
7. Right, good. So now how will you write the configuration then?
Two, 5,
Configuration? 2, 5. This is how we write, right? 7, 2, 5 is how we write it, right? So for me to form octet, what should be done? For me to complete octet, what should be done?
So 3 more electrons to be added.
Are you guys speaking?
sir. It should gain 3 electrons, sir.
Yeah, it should add. I should add 3 electrons to nitrogen so that it becomes 2, 5, and obviously if I 2, 8, right? Now what should be the formula then? The ion. What should be the ion? If I add 3 electrons to nitrogen, it will become
N3 minus.
3 minus.
N3 minus. Absolutely true. This we didn't see when we talked about reactions, chemical reactions and equations. This is another ionic, and remember, nitride is N3 minus. Okay, nitride is N3 minus. Good, good. Right. So now I think you'll be able to form the compounds, right? Say if I give you, say, magnesium plus nitrogen will form, what will be the formula? I know magnesium forms what ion? Nitrogen forms what ion? It's the nitride. What should be the formula here?
Mg3N2.
Absolutely. Right? Mg3N2. What is the name of the compound?
Magnesium nitride.
Absolutely true. Very good. Very good. It's called magnesium nitride. Right. Okay. Let me ask someone in particular. I have aluminium plus nitrogen. Let me ask someone in particular. Say. Okay. Janvi, are you there, Kana? Janvi? Are you there in the chat, Janvi? Sir, were you asking about BAV, about the exams? Okay, we'll come back to that later. Anyways, Janvi, are you there? Okay, Janvi, I think, has a problem. Fine. Maybe I'll ask... Okay, let me ask Aditi then. Aditi, are you there, Kana? Aditi? Aditi, are you there? Okay, guys, wait. Okay, fine. Aditya, are you there? Is there a problem with my connection? Everybody is able to hear me, guys?
Yes, sir.
Okay,
Yes, sir.
fine. I don't know what's wrong with Aditi and Janavi. Okay, maybe I'll ask. Okay, Vaishnavi, are you there, Kana?
Yes,
Vaishnavi?
sir. Yes, sir.
Okay, good. So Vaishnavi, what is the product formed here? Al plus N2. What will be the formula of the compound and what is the name of the compound?
Sir, the name is aluminium nitride, sir.
Okay, the name is obviously going to be aluminium nitride. Good. Formula?
ALN, sir.
Very good. ALN. That's it. Very simple, right? Because I know aluminium forms Al3 plus, N forms N3 minus. So obviously 3 gets cancelled. All you have is ALN, aluminium nitride. Okay, right. Good, good. Fine. So that's about metals with nitrogen. Very simple. All you have to remember is nitrogen forms nitride. I wrote nitride here. It's D. Okay, fine. Nitride ion, which is N3 minus, and all you have to do is just swap and get the formula. Right. Good, Vaishnavi. Good. Moving on. Say metals with phosphorus. Right, very rarely it happens, but still the reactions are predicted. Metal plus phosphorus. Can someone tell me what will be the name of the compound? Say this is your fourth reaction. Metal plus phosphorus. Can anybody guess what will be the name of the compound formed?
Metal phosphide.
Sorry, metal?
Is it metal phosphide?
Metal phosphide. Yes, very good, very good. Metal phosphide, IDE. Again, you see, very simple. Just like nitride, iodide, chloride, oxide, all these things, just like phosphorus, will form phosphide. Okay, very simple. Now tell me, guys, we already discussed this. Phosphorus exists in atmosphere in what form? Phosphorus is something very unique, right? Compared to other non-metals, it exists as something. What it exists as? We already discussed this.
Sir, polyatomic.
Sorry?
Sir,
I didn't hear what you
polyatomic.
No, it's not. Are you saying it's monoatomic?
No, sir, polyatomic.
Yeah, obviously it is polyatomic. What exactly is the formula?
So P4.
Huh?
P4.
Yeah, absolutely. Yes. Very good. Who told this answer? Who was it?
Sir, Durlab, sir.
One second. My network is, my sound is it, I don't know. Who was it?
Sir, Durlab.
Durlab. Okay, Durlab. Good. Very good. Very good. You remember. Right. So it is going to be existing as P4. This is the only one of the... Oh God. 1 second, guys. Okay. Right. So almost all the non-metals will exist as in diatomic form, right? But phosphorus, sulfur, these are the elements will generally exist in more than say triatomic or tetratomic or pentatomic forms, right? Remember, phosphorus will exist as P4. Okay, fine. Can someone tell me what is phosphide ion? What is the formula of the metal phosphide ion? What ion does phosphorus forms? Okay, first thing, atomic number of phosphorus. Anybody knows? Phosphorus atomic number?
Five, sir.
Sorry, how much?
5, sir.
5. How is it 5? 5 is boron, right?
Sir, is it 15?
Yeah, 15. That's the atomic number. Right? Now, nitrogen it belongs to nitrogen family. Anyways, we don't have to go into the details. phosphorus is atomic number is 15. Now let me tell you some interesting facts about phosphorus. Okay, right? Do you know where phosphorus is used? Any idea? Anybody knows where phosphorus is used? Okay, let me tell you then. So remember, phosphorus can exist in 3 forms. One is what is called as white phosphorus. The other one is what is called as black phosphorus. The other one is what is called as red phosphorus. Okay, like how do you have carbon can exist in graphite or diamond, or you must have heard this term, I think. Allotropes. Did you hear this term anywhere?
Yes, sir.
Right. Allotropes are nothing but same element in different physical forms. Okay, same element in, it's like clones, but yeah, not clones are exactly same. Let's say a non-identical twin, something like that. Twin, but not exactly same. Right. So allotropes are basically same elements, but in different physical forms. Say carbon only, but carbon in the form of graphite, carbon in the form of diamond, carbon in the form of graphene. Right. Same way, phosphorus can also exist in white phosphorus, black phosphorus, and red phosphorus. Okay. Now, where it is used, if you ask me, I would say white phosphorus is used in magic tricks. Okay. Now, oh God, this Mylapore, so many things are good about Mylapore, but this is really not good. Okay, anyways, so what I was telling is phosphorus, this white phosphorus is going to be used in magic tricks. How magic tricks? Let me tell you, right? So to understand that this white phosphorus, it can be, I would say it's highly inflammable, right? But only when exposed to air. So what do you mean by this? As long as you close white phosphorus in a container and keep it, no problem, right? But the moment you open it, it is going to be so reactive that it is going to burn. Very reactive, white phosphorus.
So
Okay, again I repeat, when you close white phosphorus in a container and keep it, no problem, airtight container, right? But the moment you open it, expose it to the atmosphere, or say expose it to air, right? It is going to burn very fast, right? So now, during magic tricks, I don't know whether you remember this also. Teepuri Tirumugam, comedy, famous comedy, right? Vadivelu jokes. Have you seen? Teepuri Tirumugam? No? Please do not tell me no. Did you see Teepuri Tirumugam in Aditya channel, Siripuli, all that you No? Nobody?
No,
the
sir.
name I have not heard, sir, but I see those channels.
Okay, I know it is very old. Yeah, the movie came when I was in school. Anyways, not a big deal. So you must have seen magicians doing like this, and they will get fire on their thumb. Have you seen at least that? And so
Yes,
many
sir.
people have done. They do like this. They just close it like this. The thumb will be closed. Okay, but the moment they do like this, they will get fire here. Right. So what they do here is basically between your nails, basically between your nail and the skin, right? In the middle part here, right? They will put phosphorus, white phosphorus. Obviously, white phosphorus you will not be able to see because it is white in color, right? So they will be closing it like this. Okay, the magicians. But the moment they open it and show it to the atmosphere, it will start burning. Do you get the point? Right? So that is how white phosphorus is used in magic tricks. Okay. Now, one more very famous things I'll tell you. Where black phosphorus and red phosphorus is used, same property they have. They are highly inflammable, but not as much as white phosphorus. Okay. They need some activation. Okay. They need some activation. Right? Now, let me tell you, these are the ones which are used in matchsticks, right? At the end of the matchstick, you will see only two colors. One is black color at the end of the matchstick, right? The other one is what? Red color. Those two are the only possibilities. And those are nothing but black and red phosphorus. Okay. So I told you that when you just show it to the atmosphere, it will not burn. But the moment you strike it, give some activation, then they'll burn again. Right? So remember, white phosphorus is used in magic tricks, black phosphorus and red phosphorus is used in your matchsticks. Right? The end, like you have the chemical there, right? That is nothing but black phosphorus and red phosphorus. Okay, today you learned a good information, right? Remember this, right? Okay, so now, fine. Now we all started this because we want to form phosphide. Now tell me guys, phosphorus is atomic number 15. How will you write the configuration? Called electronic configuration?
Two, 8, 5, sir.
Yeah, 2, 8, 5. Okay, that is how you write the configuration. Okay, so now tell me how many electrons should be added or removed and what ion does phosphorus forms?
Sir, 3 ions should be added, sir. So the formula is
Sorry.
3 minus. 3 ions should be added, sir.
3 ions should be added?
Electrons, sorry, sir.
3 electrons should be added. Very good. Plus 3 electrons. Okay, so it will form what?
P3 minus.
Absolutely true. Okay, it is going to form P3 minus. Okay, right? Fine. So that's about phosphide. Now we can now it's very simple. Say sodium plus, whenever I write phosphorus here, I write P4. Remember this, I don't write P2. Right? Whenever I write a reaction, I write it as P4. Okay, fine. I am going to ask someone to give me the formula for this. Maybe. Okay, Sanya, are you there, Gana?
Yes, sir.
Oh, okay. He came. Sanya, are you there?
Yes, sir.
Okay, Gana. Can you tell me what will be the formula here, Sanya? Sodium plus phosphorus will form, obviously. First, the name. Can you tell me what is the name of the compound?
Sodium phosphide.
Sodium phosphide. Very good. Formula. I told you phosphorus forms P3 minus.
Na3P4.
Good. Na3P. This is sodium phosphide. Very good. All you have to do is just switch. I'm not spending much time on all these. I'm just giving you the variety, what and all is possible. Okay, right. Fine. So that is about metal plus phosphorus. Anything else I need to tell you? Maybe carbides and all, I think will be too much for you. No. Carbides will not be there. Anything else is there? Okay, I think that's it. That's about metals plus non-metals, and that is about metals as reactivity, people. Okay, these are all the reactions you have to know regarding metals. Right. Okay, now we'll move on to non-metals. Very few reactions are there because most of the reactions we already completed. Right, most of the reactions we already completed with respect to metals plus non-metals. Okay, right. But metals, non-metals will also react, right? Say generally, first reaction we'll see, non-metals plus oxygen. Again, basically, or I can just put the first column, the first reaction as non-metal plus a non-metal. We'll see what happens. Okay, non-metal plus a non-metal. We'll see what will happen. Right? Can you tell me any one reaction where a non-metal and a non-metal reacts to form a compound? Any one reaction? Can you tell me? There are so many reactions.
Carbon plus oxygen forms carbon dioxide.
Very good. Very good. You see, carbon plus oxygen forms carbon dioxide. Right? Now you see, if you look at this, carbon is a non-metal, right? Oxygen is a non-metal, but the compound is formed. Okay, so what can I tell you is that, oh my God, this is so irritating, this outside fellows. I need to really change my place. Okay, anyways, so now remember, guys, metal plus non-metal, if they react, generally, most of the time, right, they will form ionic compounds. They will form ionic compounds. There will be a cation and there will be an anion, always. Because you see, all the reactions we saw, all the reactions you must have seen before, there are always Mg2 plus N3 minus, Al3 plus N3 minus, P3 minus, all these things will form ionic compounds. There will be a cation, there will be an anion. Right? But whenever a non-metal and a non-metal react, they will only form covalent compounds. Right? They will only form covalent compounds. Why this happens, we'll see later. When you go to periodic table, right? When you go to periodic table, at that time, we'll try to understand why is it like this. Okay, right? Fine. Now, generally, what I have to remember is, people, non-metals are electronegative in nature, right? Just like we say that metals are electropositive in nature. We can always say that non-metals are electronegative in nature, in the sense that they will always form negative ions. They have tendency to form negative ions. And how do you form negative ions? By gaining electrons. Very simple. This one we already know. The new term, negative, right? The new term is, what is this being electronegative or electronegativity, we call it. Okay, right, fine. So we are seeing metal plus non-metal, right? So I told you that they're going to form covalent compounds. And very simply, you can see carbon plus oxygen forms carbon dioxide. So we can take the general reaction as non-metal plus oxygen, right, to form product. The product name might be different, right? Okay, so now you see carbon plus oxygen forms carbon dioxide. Any other reaction like this, you know, but I mean, the same of this oxygen comes along with the non-metal. Any other reaction, guys? Any other reaction, do you remember? With oxygen coming, reacting with another non-metal.
Sulfur plus oxygen gives sulfur dioxide.
Ah, good, good. Sulfur plus oxygen forms two oxides, SO2 or SO3. Two oxides are possible. Okay, remember this for sulfur. Okay, either SO2 or SO3 is possible. Okay, sulfur dioxide or sulfur trioxide. Okay, that is carbon dioxide. Okay, let me write the names. This is your sulfur dioxide. This is your sulfur trioxide. Okay, right. Any other reaction?
So hydrogen plus oxygen give water.
Ah, very good. Okay, hydrogen we cannot strictly consider as a metal, but still it's okay because we write it as H2 will form H2O. Very good, very good. Water. This is also a reaction. Yes, anything else? Anything else? Look at the various non-metals you know and just try to combine with oxygen. See whether you're seeing something or not. I'll give you 10 more seconds and then I'll answer. Okay? Okay? So the answer is nitrogen, right?
So nitrogen plus
many
oxygen
types
give
of
nitrogen oxide.
there are so many oxides. Okay, N2 plus O2 will form NO, N2O, NO2, right? I can even form N2O5, right? So many types of nitrogen and oxygen combine together to form so many different types of oxides. Okay, now among them, one of them is what is your laughing gas? Which one is it? You must have seen in some new movies, right? So there's something called as a laughing gas, and one of them, and out of the four, one of them is my laughing gas. Which one is that?
Nitrous oxide.
Nitrous oxide.
Nitrous oxide means NO.
NO2, sir.
Yeah, NO2. Right? NO2 is what is your, I'm not, one second. Let me check. Can someone quickly Google me and tell me the answer? What is laughing gas? Quick. I think it's N2O. I'm not sure.
Yes, sir. N2O.
N2O, right? Yes, correct. Right, laughing gas is N2O. This gas has a very special property that if you inhale the gas, you'll start laughing. Right, I think there was some like recent movie also in Tamil which used this. I don't remember the movie name, but a lot of English movie use this. Lot of English movies. Okay, right. So now you saw so many different types of oxides. Now NO is what is called as nitrous oxide. Okay, N2O is, now I'll write this side. It's called dinitrogen oxide. Right, now this is called nitrogen dioxide. Okay, and this one is called dinitrogen pentoxide. I can even form N2O3. Okay, now in this case, it would have been called dinitrogen trioxide. Okay, so you see so many types of oxides can be formed with nitrogen. Again, obviously there will be reaction conditions. The temperature will be different. The pressure will be different. The pH will be different. The catalyst might be different. Right? Oh, battery is running low. 1 second. Now it's fine, right? So you see so many types of compounds are possible depending on what are the reaction conditions, temperature, pressure, catalyst, right? Different catalysts, different products will come. Different temperature, different products will come, right? Anyways, like this, there is one more thing possible with this carbon and oxygen. What is that, people? Other than carbon dioxide? Other than carbon dioxide, can I form any other oxide with carbon and oxygen?
Carbon monoxide.
Carbon monoxide.
Ah, right. You include that also then, right? C plus O2 forms CO, carbon monoxide. Okay, right? This also you can remember, right? Same way you see sulfur will form SO2 and SO3, right? And actually, hydrogen plus oxygen forms H2O, and there is one more thing possible. Can you tell me what is that? H2 plus O2 can form one more thing. It is used, okay, I'll give you a clue. It is used for when you get hurt, when you get wounds on your, say, knees or hands, right? They will use it for cleaning, for dressing.
Hydrogen peroxide.
What?
Hydrogen peroxide.
Ah, good, very good. It's called hydrogen peroxide. Formula?
H2O4.
Ah, good. It's called the formula is H2O2, right? I don't know whether you got hurt. If you get hurt, they will just take it'll be white color, I would say a whitish gray color bottle, transparent almost, right? And if you put it on your wound, lot of that, lot of effervescence will come. Lot of, like, say, pongi varadu they say, right? That will happen. That is nothing but H2O2. It's a disinfectant. right? H2O2 is a disinfectant. Okay, now you see, this peroxide is different from oxide. Okay, peroxide, the ion is O minus. Oh God, 1 second, guys. Okay, right. So hope you understand what is H2O2. Right, H2O2 is hydrogen peroxide, and this peroxide is different from normal oxide. Normal oxide is O2 minus. Okay, peroxide is O minus. See, this all are just extra informations. Okay, like getting 100 marks in science, or say at least in chemistry, out 30 out of 30 or whatever it is out of your 100 is very easy, right? But 10th is the class, right? 10th is the class. You can learn a lot of extra things. Okay, getting marks is anyways you'll get mark, anyways you will study, anyways you'll do something to get marks. But these things are very, 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 very important, because these are the ones which is going to form the basis for your 11th class. Okay, remember normal oxide is O2 minus, but peroxide is O minus, right? Okay, anyways, that's a good thing to know now, right? So we saw nitrogen plus oxygen, all with oxygen we saw, right? Anything else is there, guys? Okay, fine. I think this is enough. These are the famous ones. See, I can even have phosphorus undergoing this reaction. It will form phosphorus oxide, but I don't want to go into that details, right? Say next. We can go to metal, or sorry, non-metal plus hydrogen. You must have seen so many reactions. Come on, tell me. Any non-metal, basically hydrogen will exist as H2, right? Tell me. Anyone? There is one famous one, right? A non-metal reacting with hydrogen. There is one famous reaction. Or at least the compound is very famous.
Hydrogen sulfide.
Sorry?
Hydrogen sulfide.
1 second. Now you tell.
Hydrogen sulfide.
Hydrogen sulfide, yes, that we already saw, right? Definitely. But in that case, fine, we can take into account, but we already saw that, right? H2 plus H2 will give you H2S. Okay. Other than that,
Oxygen.
your voice is breaking. What?
Oxygen.
What?
H2O.
Can I just type it, Kana? Please. Type it in the chat box. Oh, Aditi, you were texting me in this thing when I asked you the question. I'm sorry, I didn't see. No problem. Okay. Anyways, H2 plus O2, H2O. Yes, absolutely. Right. We already saw that. Right. Any other thing, Sanya, or anybody else?
So hydrogen plus chloride.
Hydrogen plus chlorine. Okay, that's a new one. Right. Hydrogen H2 plus Cl2 will form what?
HCl.
Good. Okay. Okay. Like this, anything else? This is a good one. Nice. This I didn't think of. Good. Anything else? Okay. I don't know whether you know this. If I give you the clue, say that is going to be a gas. Okay, the thing which I'm expecting, that is a gas, and that is used in fertilizer industries. You know, fertilizers, right? For agriculture, it is used in or if you are biology, if you're studying biology, it has something to do with leguminous plants. Have you ever heard these terms? Leguminous
Yes, sir.
I forgot. I think, fine. Anyways, I forgot the spelling, but all I remember is the word. What is that gas, people? I know it's nitrogen, but nitrogen in the roots will form something else. I almost told you the answer. So one thing is hydrogen. The other thing I told you just now. So if they combine together, what will
Ammonia, sir.
Ammonia.
Yes, absolutely. Right. So I'm going to have N2 and H2 combining together to form ammonia. Right. Now this is a very famous reaction. Okay. This reaction is called Haber's process or Haber's reaction. Okay. Now this will not happen just like that. Okay. You have. Right. So I told you this reaction will not happen just like that. You have to go for, say, 600 degrees Celsius, 300 atmospheric pressure. You have to use iron as a catalyst also. Okay, the iron, Fe, metal, right, will be used as a catalyst here. And look at the temperature and pressure, 600 degrees Celsius, 300 atmospheric pressure. Okay, right. So anyways, you don't have to remember all these, but all you have to remember is ammonia, N2 plus H2 forming ammonia. Okay, we even saw H2 plus O2 forms H2O, H2 plus S2 forms, what is that, H2S, right? All these things we already saw.
Sir, iodine plus hydrogen.
Iodine plus hydrogen will not directly react, Kana. So why? Because H2, actually it will react, yes. H2 plus I2 will form HI, hydrogen iodide. Possible, yes. Just like how Cl2 is reacting, all halogens, generally I can say H2 plus X2 will form HX, and X can be F, Cl, Br, and I. Okay, all the reactions are possible. Yes. Okay, right. Anything else is there? Ammonia, we told, oxides, we told. Okay, now actually, guys, there is one reaction I forgot in metals only, right? Say the fifth reaction is metal plus hydrogen. Okay, right. Now, okay, we are talking about metal plus hydrogen. Can someone guess what will be the product here? Name of the product, obviously.
Metallic hydrogen.
Metal hydrogen, that's how you complete. What did you do in all the other cases? When I have metal. Good. Right. It's called metal hydride. This is a new one again. See, guys, hydrogen has one electron in its valence shell, right? Only one electron, right? Now, I can add one electron plus one electron to form hydrogen to be H minus, right? And obviously, I can remove this whole electron to form H plus. This we already know in the form of acids. Is it not? But when I add one more electron, the configuration of hydrogen becomes 2. That is duplet satisfied. Is it not? So this H minus is nothing but your hydride ion. Okay, this is again a new thing you can know, right? H minus, H plus is hydrogen ion, we generally call it, but H minus is what is called as your hydride. Okay, right? So we'll see one example also for this. Calcium plus H2, obviously hydrogen we write as H2 only, right? So calcium plus hydrogen will form what? Formula. Calcium, what ion it forms? Calcium, what ion? Calcium, what ion? Atomic number calcium? These is simple things. If you don't remember, guys, it will be a huge problem in writing simple reactions. Okay, let me go to that place. where I think gave you some metals which will form +1, +2, and +3. Yeah, look at this. All of these will form +2, right? And I said, I think some of them will form +1, and aluminum is the only one that will form +3. And iron also forms +3. Okay, so anyways, you see calcium here. Calcium forms +2. If you're wondering how calcium forms +2, calcium atomic number is 20. So you write 2, 8, 8, 2. This electron is lost. So Ca will form Ca2. Okay, octet satisfied, right? So now, yeah, now tell me what is the formula for obviously the name first. Name would be, yeah, that is very easy.
Calcium hydride.
Calcium hydride, right? Okay, what will be the formula now? I told you Ca forms Ca2 plus, and hydride, I know what is the formula.
CaH2.
CH2.
That's it. Very simple. Ca2 plus H minus, just flip swap, you'll get CaH2. Hydride, it's called calcium hydride. Okay, right, fine. I think, what is the time, people? 9:25. I think we are almost done. But non-metal plus hydrogen, there is just one more I want to know. One more reaction. Just like you saw sulfur, oxygen, halogen, nitrogen, all these things, right? There is one more non-metal which will form famous compounds. Very famous. Like say, if I have to give you a clue, in Tamil Nadu, protest is going on for that. In Tamil Nadu, protest is going on. Or I don't know whether protest is going on, protest was going on very recently. So, or another clue, when people who works in septic tanks, say the corporation people, right? Sometimes, not here in Tamil Nadu, I've never heard this case, but somewhere you must have seen that, you must have heard at least that the septic tank people went inside and then they died because they inhaled this gas. Or what else clue? Okay, this clue I'll give you. It is not the same thing, but same little similar to that, whatever I'm expecting. It is used in your LPG. What are the gases used in LPG, guys? LPG cylinders. What gas is used there? Have you ever seen? Have you ever looked at the cylinder and see what gas is that? Don't tell me it is liquefied petroleum gas. No. What is the formula? Or what exactly?
Is it hydrogen cyanide?
Hydrogen iodide? No. It is something else.
Cyanide, sir.
Hydrogen?
Cyanide.
Thionide? No.
HCl, sir.
HCl? No.
Yes,
HCl,
sir.
hydrogen cyanide. No. If you have cyanide gas, you will die. Okay? Terrorists use that. Cyanide. They'll have HCN in the bottle in the form of a dog tag. They will just put it as a chain. Whenever, say, the army comes or the police comes, they will just bite it and they die, commit suicide. It's very poisonous to our health. Okay, cyanide gas. Okay, so what I'm expecting is this. Methane, right? Did you know that protest is going on in Tamil Nadu? Methane?
No.
No, sir.
Okay, you don't know? Not a big deal. This is why you must start watching news, right? And obviously, because of this gas only, I told you when septic tank people goes inside, there'll be like from the methane. Lot of methane is say evolved from the excretions of human excretions. Okay, from the human excretions, not okay after some time, right? After it goes into the septic tank and all, you will see that a lot of methane will be produced. And that methane, so much methane, if you inhale, you will eventually die. Okay. And you during your LPG, right? LPG contains oh, you do. I am so sorry. You don't know this. You're still in 10th class. I totally forgot that. Right. So anyways, the LPG is nothing but pentane plus butane. Okay. So pentane is nothing but C5H12. Butane is C4H10. Anyways, you don't have to worry about any of this, guys. It's my mistake. You'll again see this in your carbon and its compounds chapter. Okay, at least this you must know, right? See, CH4, methane you must know. That's a common example, right? So again, how will you form methane? Very simple. Carbon plus H2 will form CH4. Again, non-metal plus H2 is forming CH4. Okay, right? Fine. I think the chapter is over, people. Okay. Is there anything else I missed? Everything I covered? Did I miss anything, people? Did I miss anything, or is everything fine? Okay, check it out. Check your textbook and see whether I have taught you everything or not. If not, please let me know. I will teach that, whatever is missing. I think, but I have completed everything. There is nothing missing here. Okay. Any doubts? Anybody has any questions? Okay. Yes,
Sir, when a non-metal reacts with oxygen, sir, to form different forms, like how are the forms, sir? Like sulfur plus oxygen, sulfur dioxide, and sulfur trioxide, sir. How are they formed, sir?
Good question. So, for example, if I take, say, SO2 and SO3, right? Now, say I have 10 grams of sulfur, right? Say, if I add 20 grams of oxygen, I'll be getting SO2. But same 10 grams of sulfur, you add, say, 30 grams of oxygen, then you'll get SO3. That is one of the ways, right? By increasing or decreasing the amount. Because obviously, in SO3, there is more amount of oxygen required, right? In SO2, compared to SO3, little amount of oxygen is only there because there are only 2 oxygen atoms. Here in SO3, I have 3 oxygen atoms. That is one way of looking into it. Second way is that by changing the reaction conditions, in the sense that, say, NO, nitrous oxide, nitrogen plus oxygen forms NO, that will happen, say, at 300 degrees Celsius, right? But say N2 plus O2 giving N2O will happen at, say, 400 degrees Celsius. You get the point, right? So different reaction conditions, different amount of reactants. When I say reaction conditions, 3 things can come. One is temperature, pressure, and catalyst. Depending on what catalyst you use, you will get different products sometimes also. That is also a very good possibility. Okay, did I answer your question, Durlabh?
Yes, sir, I understood.
Right, okay. Anybody else has any other questions?
And why do metals have different valencies, sir? Like iron has valency 2 and 3.
Absolutely. Again, a very good question. But you are not equipped enough with chemistry for me. Even if I answer, you are not in a position to understand it. Okay, hold on to this question. Ask me this question when we come to 11th class. Okay, Sanya? Okay, right. Or if you're interested, go read about it in Google. But I'm sure that you'll not understand anything. Why is it like this? Okay, so why is it like this is because now you know one way of writing the electronic configuration. You know, say 2, 8, something you write, right? But there is another way of writing the electronic configuration in terms of something called as subshells, SPDF. Okay, once you understand that, then you can understand why is it that multiple oxygen. Even see phosphorus. Okay, phosphorus can form a cation. We generally saw only P3 minus possible, right? But phosphorus can form P3 plus and P5 plus. Okay, now why all this happens, we will definitely understand when you go to 11th class, right? Now, right now, you are not equipped enough with enough science, enough chemistry for you to understand. But a good question. Hold on to this. If you're really interested, please go check it in Google. But if you want to discuss, sir, I understood this, I didn't understand that, you can always text me. I'll help you with that. If at all you want to learn more, why not? Now only you can learn more. But that cannot be given in a forum of group of people. If you are alone interested, yes, we can do that. Okay, Sanjay.
Okay, sir.
Right? Okay. Any other questions anybody has? Okay, fine then. Thank you so much, people. We'll meet again next week. Right? I'm ending the class.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir. Happy Teacher's Day, sir.
Thank you. Thank you.